or that are following through the internet connection. Today we have the third seminar, monthly seminar that we are organizing in the Institute of Advanced Materials for Sustainable Manufacturing. And today we are going to have a tremendous topic that is regarding to artificial intelligence. And you may see the title here, Future Farming. You may realize the importance of future farming to all of us. Well, today we are going to listen future farming, intelligent artificial and technology transforming the agriculture industry, that is going to be given by Dr. Rita Fuentes Aguilar. You know, Dr. Rita Fuentes Aguilar is currently a researcher at the Institute of Advanced Materials for Sustainable Manufacturing at Tecnológico de Monterrey, and is leading the research group with focus on enabling technology for accelerating of material development. Her research is related to mathematical modeling, identification and control, biomedical applications, machine learning, and artificial intelligence too. She is, by the way, an expert on that area, so it's good to have Dr. Rita Fuentes, because you know, recently, Elon Musk and other people are claiming that we need to stop artificial intelligence for at least 6 months. But today we're going to listen the importance of not stopping that kind of technologies, especially speaking about farming and food, okay? So, Rita Fuentes also, she's part of the national research system. She's actually level 1, so, but she's moving very fast, and very shortly we're going to see Rita as level 3 for sure in this system that we have in Mexico. Dr. Rita Fuentes is also working in robotics, artificial intelligence, and computational vision areas. Dr. Fuentes is also concluded her higher education in biomedical engineering, and now he's also moving into agricultural areas. There is a lot of connection in the world. It's something that we need to focus, to be multidisciplinary, to be able to work in different areas. Basically, science join all subjects, okay? So, and Dr. Rita Fuentes is working also in these areas. Also, I would like to mention that Dr. Fuentes, she graduated from the Research and Advanced Studies in Cinvestav, that is a top center in Mexico and in the world. She has also been doing research or running projects, more than 20 projects with industrial applications. And also, some of those projects have been sponsored by the National Council for Science and Technology here in Mexico. And well, I may spend the whole hour speaking about Rita Fuentes' background. So it's a good idea, better to introduce Rita Fuentes to come here and to start your talk. That we are looking forward to enjoy it and put a lot of attention. It's very, very important to pay attention, because artificial intelligence is something that we are really look forward to apply in all our activities. Dr. Rita Fuentes, welcome to our third seminar. It's a pleasure to have you here.
Thank you so much, Dr. Alex, for this presentation, amazing presentation. Thank you. And well, I'm going to talk today about future farming, and I put here some pictures. A picture of the place I work at. It's in Campus Guadalajara, Tec de Monterrey Campus Guadalajara. That's the engineer building, and that's the building for research in Campus Querétaro, because I work in these two campuses. And well, to start, what is the definition of agriculture industry or agro-industry? One of these definitions that I found is that industrial agriculture is the large-scale intensive production of crops and animals, often involving chemical fertilizers on crops, the routine harmful use and antibiotic in animals. I mean, it's not just agriculture, it's also animals. It's also all the part of not just cows, as you can see in the picture, but all the animals we use to eat as food. Another definition, it's all the sectors that are involved in the food industry. All the transformation we do from the animals, from the plants, to convert this in something that we can have in our tables. That's the other definition. And it involves also all the food services and manufacturing food services. So this is all the food area, food industry, that it's very important here in our country. And finally, the third definition is the definition we have here in Mexico. For this, we say that agro-industry is the economic activity, so it's very important because it impacts directly in the economy of the country and moves a lot how the country is moving in this area. Includes the production, industrialization, commercialization of agricultural products, and it not just stays with, again, just with plants and animals. It puts also forestry and fishing. I mean, it takes all of the other concepts that in the other definitions are not mentioned. This is very important then economically and also for our lives and in the society. In the past, when we talk about the use of modern technology in agriculture, we talk about chemical fertilizers, pesticides, herbicides, using in the field. Using the machinery such as tractors and artificial selection of seeds. This part of selecting the fruit that is much beautiful and taking the seeds there to have much beautiful babies of this fruit. And the same with the cows and the same with everything I want to produce. I choose the best, I choose the most beautiful to have much beautiful plants and products. That was we call in the past modern technology. Right now, what we call modern technology is not something that I'm gonna think about in the future. It's something that is happening right now. And it's the development of new agro inputs, this transformation and the use of not just these chemical fertilizers, pesticides and herbicides, but new technologies that could reduce the damage in the field. The use of robots, drones, automatizations and satellites, and the genetic engineering in the seeds. Everything, all this that I mentioned, it's now a reality, something that is happening. It's some things that we have that there is industry selling drones to do the work in the field. There is automatization in the field, in the big areas. Automatizations even in the cows, I'm gonna mention something about this. And also genetic engineer. And the most important part about moving to these new or modern technologies is that we have to look for sustainable solutions in the agriculture area. As you know, farming is a major emitter of greenhouse emissions. Everybody knows that. Even if you talk mostly, for example, with people who prefers vegetables over meat, they say meat is the one who has the bigger emissions. And you talk with people who like meat and are gonna say, no, vegetables are the ones with the bigger emissions. If you see really, it's both of them. All of this part of the agro industry, it's the one with the biggest greenhouse emissions. The companies are trying to move in how to make their process much more sustainable. I showed this graphic because we have like the main sources of production emissions are in the animals, but are also in the energy we waste to weed and to harvest the products in the field. The methane in rice is like something that produces a lot of contamination and wastes a lot of water too. So it's very important to talk about it. The soil fertilization, which is also a big issue. And why? Because normally it's not so optimized. They spread all the pesticides, herbicides, and everything they need, and the fertilization, and they don't care if the plant really need it or not, because it's general in all the field. So this is not optimal at all. And farming has not been in no doubt a huge contributor to the emission of climate change. So it's very important to do something in this area. It's very important to pay attention to the agricultural process. So that's how smart farming born. It starts because we need to reduce these emissions and we need to do something from the technology. And one of the parts that we taught here in the smart farming is from artificial intelligence in agriculture, but also combined with robotics and other technologies. The first one is agriculture robots. and which is something that I'm gonna talk much more after this. And is the use of these autonomous robots for harvesting, but not just for that, for weeding too. Crop and soil monitoring, and in here we use machine learning and artificial intelligence, and what we try to do is make diagnosis over the field, diagnosis over the plants, diagnosis over the state of maturity of the fruits, etc. The last one is the disease diagnosis. This is very, very, very important. You don't know, but plants can have pandemics too. They could have a virus attacking or a bacteria attacking and making that all the field start dying. The contamination of one part of these plants can go to another and another and another, because the air takes a lot of, the wind takes a lot of, a big part on this. So it's very important to solve these problems in order to not to lose all the herbs. That's an example, detecting with artificial intelligence if the plant has something, a bacteria, a virus, some other thing, a fungus or something that is affecting it. I don't know if you like plants. I'm the plant lady. I'm just get married and go, I don't know, you thrown into that. You start buying plants. And something that happen a lot, it's that kind of things of parasites. You have those and you try to eliminate, and you can't, and you say, how is possible that in the streets the plant is so beautiful and in my house it's dying? Well, that's something that it happened in kilometers. It's something that it's much more strong that it happened in your house. The predictive in science, it's another thing. It's normally for this you use digital twins or virtual reality. I saw that here you have a beautiful place for virtual reality. And why we need that? That's for predictions. Normally you use it and generate a mathematical model that tell you what could happen if the weather conditions change. That could change a lot of things in your field. If the water, if there is no water, it's gonna be a problem. But if there is a lot of water, it's also a problem. So all of these you have to take in mind and have control, and to predict it's going to happen, so I have to be prepared. Another is intelligent spraying. That's now like something that happens a lot. Normally they use drones for this task. And the thing is that the sensors have to detect the weed in the affected areas and only spray in that affected areas. And that's one of the most sustainable parts of these technologies. It's sustainable because it only attacks the parts where it's needed. So you don't have to waste a lot of material. You don't have to affect the other areas. You don't have to affect the people that live near to these areas. So it's one of the most effective solutions that exist right now. And the last one is the crop yield prediction and price forecast. We know normally, or we have this idea that agricultures normally have no money. Normally they are pure, they are like people who has to, or are looking to sell their things and try to move them in order to not to lose. But the reality is that if they have just a little more information, this could change. If they know that now it's not this place a place to sell, but in this other there is demand, I can move and continue doing my job, because there is always going to be demand in different parts. So giving this information or giving information about how the other producers are selling their products could be very helpful for them. And that's another part that is solved with artificial intelligence. And a lot of this, the precision agriculture start generating a lot of work, a lot of research too. And precision agriculture is when you make something or some solution specifically for someone. Another symbol of this is in precision medicine. In precision medicine, we try to do or make the solutions specifically for you, for your illness, for your medical history, for your genetics, for you. And this is almost the same. We try to do the solution specifically for the person who is asking for. If you are someone with cows, you are going to want to have solutions for cows, but specifically for the species you are working with. And the same is going to happen in the field. If you are someone who produces tomatoes, you want solutions for tomatoes. You don't need solutions for strawberries. You need something for you, and specifically for the species you are working with. So that's precision agriculture. How do we work with this? Well, the first is having geographic information. That's something that right now it's really easy because we have GPS, so we could have this information and make some smart maps about the terrain, but not just the place where you have your tomatoes, also the places around you, because this is going to affect what happened with your tomatoes. So the information about the map of everything that is happening around, it's very important. The next one is the stress detection, knowing how the water is moving. What I mentioned before, what happened with the weather, the nutrients in the soil, the weed, if there are insects or not. Whatever is happening, you need to know in order to be prepared previously. The prescription plan, also, if you know what is going to happen, you have to prepare. You need to have some of things there in a place where you can use it when you need it. The next is the variable rate technology. Like tractors, for example, I mentioned that it's one of the things that wastes much more energy, so it's not sustainable at all. So moving from tractors to another kind of technologies, clean technologies, it's something very useful. And if you have tractors, well, use it in the better way. Don't waste much more energy than you need. And the last one is the vegetation. As I mentioned, vegetation around the place where you are working, it's very important. And not just that, also population. And after this, there was born another solution, which is the vertical farming. I don't know if you have listened about vertical farming. It became very popular because it's something you can have in your house, you can have in a small business, so it's something very attractive. And I like the Guardian who mentioned that vertical farming is no sunlight, no soil, no worries, because vertical farming looks stacked with promise. So they saw this like a very big solution, like something that could change completely the way we do the things. First of all, no sunlight. As you can see in the picture, there is no sun there. They are using LED lights. So with LED lights, you can have some plants growing in your house. So you could have plants during days and days and days, even if there is no sun for months, because it's the way they work. And the other is no soil. I'm going to show you some examples of vertical farming that use no soil but another alternatives. And the space is another thing. You don't need to have a lot of space. I'm going to call it like horizontal space. You could have one piece horizontal and another in vertical in another level, in another level, in another level. So you could have much more things to cultivate there. And the three approaches to vertical farming are hydroponics. Maybe you have listened about it. If you buy lettuce in the super, you know that overall lettuces and green leaves are selling with hydroponics. Hydroponics is the other one. And the last one is aquaponics, and I'm going to explain every one of this. The first one, hydroponics, which is the most known right now. Those are plants that are fit in a ground medium soaked in water, and this water contains some nutrients. And this is a circular cycle. It's a cycle. You have the inlet of water with nutrients, and you have a drain and water to recycle. So this is very sustainable. This water is not just go to the trash. This is not a waste. You can use it for another kind of plants, depending on what nutrients this use and what nutrients that plant did not use. So you can use it again because it's clean water. It's not something that you cannot use. And this is an example of this vertical farming. As I mentioned, you could have several levels and in very small places. This is a greenhouse. And the most common is to see just green leaves, but right now we are starting to cultivating some fruits. in this case it's chili, but you can have another fruits. It was in the past very, very difficult because you don't have enough nutrients for this kind of fruits. You only have nutrients for the leaves. So it was a challenge. And a quick guide, I'm not gonna mention all of them because there are a lot, but one thing is they don't use soil, as you can see, it's water with nutrients, that's all. Another thing is that this method allows for faster growth and higher yields than traditional soil methods, so it's an advantage. And the other one is that you can grow vegetables indoors and outdoors, so it works for both of these. The next one is aeroponics, and I put this picture because, again, if you are the lady of the plants like myself, these kind of plants become really popular during the pandemic. Everyone wants an aeric plant, and these are plants that you can have just in your house, and sometimes you put some water, but with, how you call this? And spray, yes. You just need to put some, and that's all. They are in the air, they don't need a place to put, they don't need a pot or something, or soil, nothing. It's just there. They are very beautiful, really difficult to maintain, I'm hard to say. They are much more easy plants than this one. They look beautiful, they are popular, and they are a little expensive comparing with the others. But this is just a beautiful example. If we go to the practical example, this says plants that are suspended and nutrients are delivered to roots in a mist sprayed at intervals controlled by sensors. So again, it's something that you could have very optimized. Analyze when the plant needs the water and when the plant needs the nutrients, and just spray in that moment. So you are not wasting much more water than you need, only the necessary for the plant. Obviously for this you need control of the temperature, the light, and the sensors of humidity, moisture sensors, and you need an atomized nozzle to make it automatically. That's what you need. And some examples of this are the aero towers like that. It looks beautiful even. And just in the part that looks like a pot, you have all the mechanisms and the board and the sensors. So it's easy to maintain. It doesn't need much more space. And an advantage of this over the hydroponics is that we have much more easy fruits. In this case, those are potatoes. It's an aero tower with potatoes, so it's a big advantage that we can have some fruits and some of the vegetables that we love the most. No? So that's an example of this. And the last one of vertical farming is the aquaponics. It's becoming much more popular. Right now, it's most in the research area, and there are some companies that are working with. I'm gonna show you some examples here. What do you need? You need a tank with some fish in there. The most popular fish right now is the tilapia. It's the one that is used much more in research. So you have some tilapias in some tanks, and it's again a cycle. The tilapia and the water that they use have some nutrients that are necessary for the plant, and again the plant takes some of these nutrients for the water, and what they go back to the fish is good for the fish because it's free of things that could damage the fish. So it's a cycle, and you need that, a fish tank, you need a plant, and you need these stumps or these pumps to maintain the circulation of the water. And these are just 3 examples. The aquaponic that it's presented in Future Foods. This is the performance of Nil tilapia and vetiver grass. It's just grass. It's everything that it's all they are cultivating right now. And this one is for tomatoes. So we can have again fruits and we can have fish. Both of them are comestible and they use less energy than others, and it's a sustainable solution. And we are working with University of Alberta. They have the Aquaponics 4.0 Learning Factory, and they are working with this exactly. So it's a collaboration we have with them. What we are looking is to know when the leaves are ready to be harvested. So we need to check the maturity of this and have like a follow of the metabolism of the plant. And well, all of this, it's called digital farms. It's 3 examples of digital farms, which is vertical farming. When we call that a farm became digital, is when they are start using drones, weather stations, crop registration tools, soil scanners, etc. All of these that I mentioned there are forms or ways that the farm is using in order to sensing what is happening in their fields and make control of this. And all that I'm showing here are companies that are actually selling solutions. Solutions with technology, solutions that are sustainable, solutions that waste less energy. And right now some of them are very expensive. It's like some inversion you have to do in order to see the results in the long time. But all of them exist right now. You can look for any of them and look what they are selling. And it's very interesting because some are concentrating in smart irrigation that I say it's very important for sustainable solution, farm management software, precision agriculture that I mentioned before, robotic and drones, sensors, and there you have animal data. I mentioned you how important is that having the information about, and I say a lot of cows because it's something all of us know. Have you seen the cows that sometimes have something in their ears, or maybe a necklace? When the cows have this, they are sensors. What will we want? What do we want? For this necklace in the cows, what we are looking is to take measure of the cow to know in which moment it's going to produce the best milk. In which moment I can present her maybe a bull to have little cows, babies, because it's the best moment. It's the moment when the cow is going to suffer the less, when the cow is ready, it's prepared, so everything is going to be much more easy. In which moment the cow is sick, in which moment the cow is eating less or is eating more. So with all this information, I can make decisions for the better of the animal. And that's what they are looking with these kind of sensors. And right now, it's just sensoring. They have a monitor for the animals. You can follow the monitor, and an expert has to make the decisions. But we are moving exactly to make that the artificial intelligence be the one who make the decisions in order that you don't need much more people checking for every cow. You need to tell this cow is ready, this cow is sick, this cow has stink or something, and just with that information, like giving a pre-diagnosis for them to take action. But yeah, this exists right now. And the other one is automatization, which is, again, this is not future, this is right now happening. We have, for example, the Dino weeding robot, and this robot is specifically for weeding. They put the seed, they make the hole, they put the seed, they cover the seed, they put water on it, and they check how the plant is growing. Another one is the avo-weeding robot, makes mostly the same, but also make a harvesting in a small, in the small plants. And the last one is the farm bot, which is like a 3D printing, but for make for putting the seed and make all the process that the Dino do. The Dino do it moving this just in one specific place, so it's again for small plants right now. But it's really sustainable. Why I say it protects the environmental? First, you don't need these tractors to look for all the field, where is need, where is not. A person who is checking if the soil is ready or not. If you put some sensors, you could know this space is ready, you can go and harvest. This space is ready, you can go and put some seeds. This space is ready, you need to put water on it. So specifically what they need in the moment they need. And that makes that you waste less energy. It benefits workers. Normally, if I show you a robot that can do the work of someone in a farm or some agriculture person, you're going to say, oh, they are stealing the jobs of these persons. It's not true. Right now, we have even a lack of people to recollect some fruits or to make the harvest process, because it's hard. It's a very hard job. So not all the people want to do it. So if you help these people and you put with them some of these mechanisms to make their jobs easier, it's going to be good for them. It's going to benefit the workers. You don't need as much as before because you don't have as much as before. Every year we have less, so it's something that is good. And reduce costs, as I say, it's a big inversion. Normally these robots are really expensive, but if you make the inversion, you can see that in a short time you have some retribution. And well, a digital farm, complete digital farm could be like this. You have the automatization in the greenhouse, you have the smart crop sensors, you have the smart collars in the animals, electric autonomous tractors, weather conditions monitoring, and some drones to make the spray. So this could be like the perfect digital farm. But it's not just. What I mentioned is in other countries, it's happening in other countries. In our country, there are some of these companies trying to sell their products. They are entering into our market, but it's not all, and they are not putting attention to all of the problems we have in Mexico. So this is a project we have in the unit, and the project is reduction of harvest losses in greenhouses growing raspberries and blackberries, picking berries through artificial vision systems and new lightweight material grippers. We work in Jalisco State, and specifically in Ciudad Guzman. And well, according to Agri-Food and Fisheries Information Service, there are a lot of space just in Jalisco and Michoacan that are right now cultivating berries. It's very popular. I don't know if you have seen some people sometimes in the streets selling the berries in small boxes, and you can see also in the super these small boxes with berries, strawberries, raspberries, and blackberries. It's very popular, but there are a lot. And the problem we detect is that as there is not enough workers to harvest these berries, there is a lot of waste. So they have to throw out a lot of these fruits because there is no one to harvest. So looking for this problem, and I want to say who are we? Well, it's me and a team with a leader in the robotic system, which is Dr. Manuel Navarro, and the team, which is an expert in virtual reality and digital twins and computational vision and artificial intelligence, Dr. Gustavo Hernandez and Dr. Eduardo Morales, and an expert collaborator, Dr. Ochoa, expert in data science and vision, and another team, which is who the leader is Dr. Enrique Kwan in the gripper system, expert collaboration, Dr. Armando Roman in the mechanics and metamaterials, and an expert in modeling and simulation of these materials, Dr. Angel Mora. And with this team, we are working in 3 big challenges. The first one is the control challenge. Have a robot that moves into these greenhouses, automatically do the job of go look for the berries, and then with a vision system, look if the berry is mature enough to be picked. That's what we are looking at. Look the stage of the maturity of the fruit. And the last challenge is to picking that fruit. In the moment it's ready, and the system says it's ready, the robot put in place, and then a robotic arm has to pick up the berry. For you to see, these are the fields. It's not a easy terrain. It's very difficult. It's something like I don't know how to explain it, but you can see it. This space is really big. It's not small. It's difficult to walk in it, so it's a challenge. That's a mature berry, and the others are not, and that's how you pick. If you are picking one of these, one raspberry is easy, but sometimes if you are picking another fruit, you can see it's not so easy. So it's a challenge to make that a robot do this thing. This task is not easy. So for this, we start with the control challenge. We are working with Husky unmanned ground vehicles. It's something like that. As you can see, I need that kind of wheels because the terrain is very difficult. And a robot manipulator in order to position to put the robot in the correct position and to take the berry. And that's the terrain again. And this is one of the results we have right now with the robotic arm. If we say the berry is right there, I give them some coordinates and it moves to that coordinates. And this is the team. We work a lot with the students too, and mechatronics students. In this challenge, we are also working in digital twins for monitoring and control the greenhouse. As I say, making the prediction is very important. We need to take care of these fruits. So we don't want people walking for kilometers and kilometers and kilometers looking for something that is happening in the fruits. I want to do this automatically. And the easiest part, or the much easy, or the way to do this in an easy way is to have digital twins. I mean, it's something like this. This is an example of this paper. You have the place and you have a simulation, a virtual simulation of that place. So you can monitor it and you can play of what happened if. What happened if the conditions change? What happened if the temperature change? What happened if there is not enough light, etc. And doing this with the greenhouses could be very useful for the owners. And in these teams, we are working also with Dr. Rafik from Alberta, and this is the team, Dr. Gustavo and a student, Carmen Mora. And finally, almost finally, the vision system. This is the most important because the other two depends on this. In order to move the robot, they need to know where the berries are, and in order to the gripper to pick the correct fruit, we need to know the state of the maturity of the fruit. So for this, we're using these cameras. One of these cameras is infrared camera, which gives us information about the metabolism in the fruit. And those are pictures of a normal camera, let's call it, and an infrared camera. And what we are trying to do is to make something that is called fusion, image fusion. I'm going to show you the results later. Here are the problems we have with the cameras. It doesn't matter if it's infrared or not. We have low exposure of the pictures or high exposure. It depends on the conditions in the greenhouse. Low light, because we are taking pictures also in the night. You can see there some of the team, Eduardo Morales and Emanuel de la Cruz. They are taking pictures in the day and in the night because the idea is to have a robot that can work 24 hours, which is different to the recollectors right now. This could give to the greenhouse owners much more impact in the inversion they are going to make in these robots. So it's something we are looking for. Right now we have this. It's a detection of the berries. You can see that there are two kinds, the matures one and those two are not enough mature. So we can detect these two. We are looking to detect much more deeply to know exactly the level of sugars in the plants. And for this, we are working with the biotechnology department to give us this information about what happened with the fruit and have exactly the classification. And here are some examples of how we see in the infrared cameras when we are there in the greenhouse. Well, when I say we are, I was not there. The team was there. They are the ones who are doing this. And this is an example of the fused images. What we are trying to do is a richness plan, which is not useful anymore, and the near system, and together they give me exactly the position, like very segmented, like apart from all the background in the picture. And now the last challenge that I mentioned, now yes, this is the last challenge, is the picking challenge. For this, we're designing a soft gripper with compliant mechanism. The team is Dr. Enrique, and he's working also with some students, master, PhD, and undergraduate students. And the grippers they are working at, these are some examples. You can see something like that you're going to say, that is not automatically. Right now, it's not. Right now, it's working like that. I'm going to show you how this works. We can change the palette, so the place where we can take the objects, and this can change depending on the fruit. Right now there is a lot of research of picking fruits, but for example apples are normally much more stiffness that if you have a strawberry, for example, of a berry, the softness is not the same. This happened with the avocado, for example. The avocado, when it's not ready anymore, it's very soft. But if there is in a young state, it's very, very hard. So in the changes of the conditions, we need the changes of how we are going to take the object. So this is something they are working at, and this is how we make it, or we are automatized. We put some actuators, and as you can see, they have movement, so they can close or open in order to take the object. And here you can see there is the actuator, so it opens or it closes, and it can take different elements, and obviously the gripper can change depending on the object. There are some results of what is happening there, the stress, the displacement that we need to have these elements, these objects. And here are some videos for you to see. How is this working? This is obviously without the actuator, but it's the same when you put the actuator. It's the same principle. And this is how it works. They are different models, and you can see how different they took the object. It's different for each one of these. And all of this that I'm presenting you right now is really young. It's something that we are starting to work at. We don't have years with this. We have just some months working in this. And we are working with a company, Berries, they're in Jalisco, the University of Alberta, the Metamaterials Lab in Querétaro, and we in Cyber Physical Systems Lab in Guadalajara. And this is the team, and this is the project, the 3 challenges we are facing right now with these greenhouses and with these fruits. And well, that's all for me. Thank you so much for being here.
Thank you very much, Dr. Rita, for your very nice presentation, an inspiring presentation. A lot of things we can do regarding smart manufacturing, and regarding also smart agriculture, and so on. So, to the public that is here, do you have some question or something like that you would like to address? Some questions? I have a lot of questions for Dr. Rita. Here, we are talking about precision agriculture, and also I saw that you were mentioning over there agriculture 4.0. Could you please elaborate a little bit about what you mean about agriculture 4.0 and how this impacts society 5.0?
Well, it has a big impact, and there is not something new, because we have a lot of years working on this. And we start with the industry 4.0, which is put some sensors again in these production areas in the industry in order to reduce some costs, in order also to help the workers there, and taking a lot of data. Data is right now the gold in this generation. We need that to work with artificial intelligence. We need that to make predictions and a lot of things. So the same is here. What we need is to have this data in order to optimize the way we work, in order to generate mathematical models, in order to help how this is moving. And as I mentioned, it impacts completely the society. First, the people who works or to lives near to these places, they are less exposed to things that will happen, like these herbicides, pesticides. You can reduce the impact they have into the cities, but also the water, which is used if you just use what they need, because you have sensors, you have all the field monitoring, you have all this information, and you put this in a model to predict and to optimize and to prepare the people there for what is happening. And it helps not just in the sustainable area, but also in how the works are moving. The people can see this, and I don't have to be just someone who cultivates. I can be someone who monitors. I can be someone who can understand these things and make decisions. They are the real experts. These people do it by feeling, so we need that knowledge and make what we call an expert system based on the knowledge they have for a specific the plants they are cultivating, the things they have. So it's very, very important.
It's very, and also I like it, the way that you are managing these new technologies. And I'm really glad that you are also introducing the concept of the harvester 4.0, right? The harvester is a very important. It's like in industry, we have the operator 4.0. Here we need the harvester 4.0. And you are speaking about human, robotics, and so on. What else do you think that we should do in order to have this harvester 4.0 to pick and to reduce the waste that we have nowadays?
Well, it's a lot of work. As I mentioned, a lot of the companies that are selling the products are not fully automatized. They only work into, I make the monitor and someone else have to make the decision. I work in the robot to do this like automatically without, I don't want to say it, but I want to say it, thinking if that's correct or it's not correct. So it's just mechanical. And we are moving, and that's the challenge, to make the decisions. The robot has to make the decisions. They have to reduce the work and the stress in the worker. They have to be a real tool for them. So that's the next step.
No, well, I am really glad that you are now not only presenting this problem that we have in this industry, but also adding now solutions that we need in our society. I have a question here from the public that are following your presentation. Citlali Rios is asking, can the Dr. Rita speak about her ideas to make these fantastic technologies accessible, available for to farmers?
Yeah, well, that's why we are talking with farmers right now, with the people with the problems, because if the idea comes from the engineer, it's normally something that looks fantastic, but then the farmer or the user, it's not gonna want to use it. It's something that I learned from the biomedical area. If you give the doctor what you think he needs, he's gonna refuse to use it, because it's not something that came from here, from him. So it's the same, we are working with the farmers. Looking for them that they give us the problems they have, not something I detect or something I see. You know, what I want is that they give me what they need, and based on this problem, I generate a solution. And the solution I generate is working with them. If they told me, no, you can put this because this or that, or whatever they knew before, well, I change the solution in order to give them what they need. And normally these solutions are not just for one person, it's for a lot of the producers, so it has real impact.
Oh, excellent. Also, I have a question from Arturo Molina. Dice, what are the challenges that you are facing to work with farmers in Mexico? This is a very interesting question, right?
Yeah, right now they are really open to us. They're in the state, and we have this opportunity because some of the members of the team work with them before or know them before. So this make that their minds are really open to listen what we have and to wait, because normally in the industry they want the solutions really fast. You need to give me the solution right now because I need to reduce the cost right now. So it's something that moves really fast. And with them and trying to start the project hand by hand with them, make it much more easy. The big challenge is first explain to them that it's not so fast, but they are gonna have the solution in one moment, but they have to wait and let us take the process. And the other one is showing them that we have two parts. The academic part, the research part. In this research part, you can have an hypothesis, and this is not always work. Sometimes it's not gonna work, so you need to change it, and they need to know that. And the other one is the technology. The technology could be really fast, but if you want what you need, you have to wait for the research part too. So that's one of the challenges.
Excellent. I have an additional question from Dr. Dora Eliana. Which countries use artificial intelligence in agriculture? And what is the disadvantage of artificial intelligence in this area?
A lot of countries. I found specific cases in places that I could never imagine, like Kenya, for example, in India also. They are working with this kind of process and artificial intelligence specifically. In Europe, in some places in Mexico with the industry, they are working with drones, for example. So there are several parts where they are working with. The problem with artificial intelligence is when we think we can be blind and let it work by itself and never feed this with information. When you think I just give this artificial intelligence enough food at the beginning, data, and it's going to work by itself, that's normally a problem, because this algorithm continues learning. So if you are not giving anything, what they receive is trash. So you need to take care of the model you are working with. You don't have to think they don't need me anymore. They need you. You are the creator, so they need you.
Exactly. Excellent. I have an additional question. This is my question. But before I ask that question, is, to the general public here, do you have any question? People that are working in the microalgae?
Hi, congratulations for your presentation, very interesting. Well, by your side, we work in bioproduction systems, as you may know, and we understand very well vertical and horizontal production, agriculture, and we know it works how it is right now. And we know it has a very strong sustainability basis. But which parameters or which points of view you consider to move it to the intelligent way and to keep the economic sustainability? Because sometimes, I mean, I can follow or monitor these systems with a normal technology and didn't cost that much how smart things does. And like most of these kind of process are in a small scale, they are not economically viability. It's not economically viability to transform it. How can you improve this? And over which parameter you will go to do it?
I think, again, it depends of the plant you are working with, because some plants it's much more important, for example, the changes of temperature during the day or during the month or during the year. And some, if you maintain the temperature the same during a long time, it's gonna work. So it depends of the plant. And for example, for some, temperature is gonna be very important. For others, maybe not. If you maintain the temperature in the room, it's gonna be enough. So you don't need to have sensors all the year working. So you can reduce one sensor from them. In others, it's gonna be much more important than humidity. Again, as plants lady, I can tell you some of my plants needs a lot of water much more often than others that I can forget about it and they are still live. So you need to know what the plant needs and take the sensors you need for that plant specifically.
Yes, I'm sorry. Maybe my question wasn't right, but my question is more like, why I would use your sensor that is probably really expensive beside a normal thermometer to
normally
monitor
in a small
temperature,
scale,
for example?
In a small scale, it's not going to be expensive. Normally, there is much more cheap. The sensors are easy to put in there. The sensors are easy to take just the monitor of them. It becomes much more expensive when you need a lot first, and the second is when you put some models that make much more for less. If you have just some sensors and you construct a mathematical modeling to make the automatization of all this, it's going to be much more expensive because you have just a few and all the work is going to be in the computer. So you need power in that computer. You will power in the mathematical modeling. So again, you can waste a lot of your money in the sensors and less in this, but you are going to have the monitor and you are going to need people to make the decisions for you. Or if you want not so much people and you work that the system make everything for you, then it's going to cost at the beginning the inversion, but then you are going to see the results. No? You are going to see that you are wasting less money in the long time. So in a small scale, I can tell you it's cheap. The problem is when I'm talking about these kind of fields. No? That's when it becomes much more expensive. And if you have a vertical greenhouse and you show me and it's a room like this, it's going to be cheap. But if you want to do this in an industrial way, then the money multiplies, no? The inversion multiplies. So.
Okay. And it is time for the last one.
We have time, we have time. Go
And
ahead,
the
please.
last question was, in the same model of aquaponics, do you consider it's more important to monitor the plant or to apply artificial intelligence to the control of the animals, like fish, shrimp, and others that can get sick, and maybe with image analysis you can avoid these problems, and this problem costs a lot of money, so it's justified the use of artificial intelligence, or you consider more important the plant?
I justify the use of artificial intelligence in the monitor of the animals totally, because it's not as predictable as the plant. In the plant, you could know what is going to happen in a long term, but in the animals, it's much more difficult. And as you said, if some is sick, you need to know if that sickness is going to affect the others, or it's just something that is happening to that fish. So it's something you need to monitor, it's something that you need to follow. So I think it's much more important to follow the animals in this moment. We have much more control over the plants. So that's what I think.
Thank you.
No, thank you.
We have questions. We have time for one additional question. Go ahead.
Thank you, Doctor, for the presentation.
Thank you.
Wanting to reach how far you want to go with the project, do you think it'd be better to work with government systems and institutions when publishing the results, or do you want to privatize it, or just like publish it freely and with Creative Commons to work with the agriculture companies and everything? What do you think would be better for the growth of the project and to be able to continue collaborating with receiving the information from the people who are experts at the activities,
Yes.
and like continue feeding the data into what you need?
I think we need the three parts: the academia, the government, and the industry. We need to work like a team. In Mexico, it's very difficult that just a few people do these kind of things. Normally, the researcher work in his lab alone and doing stuff maybe with another researchers, and that's all. Give the step to work with the industry, or give the step to work with the users. That's very difficult. You have a lot of inputs, different inputs. Every person thinks different. So that's a challenge. It's the first challenge. But I think we need them. If we really want to have a solution for them, because as a researcher, you are not thinking all the time, and I want my company and I want to be rich of this product. You want to know what is going to happen. Is this going to work? How is this going to work? That's what you want. You want to see this working. It's your baby. You want to see it like, I make it grow. But of course, we want that this solves something. If it solves nothing, it's just interesting for me. It has no impact. So we have to work with the users. But we need a lot of the government. In order to move the things, we need to know the politics. We need to know how the inversions of the government are working in the country. If they are not interested anymore in that industry, they are not gonna give support. They are gonna put some difficulties in the things we have to do. So we need to work with them. In Jalisco State, we have this big advantage. The innovation, la Secretaría de Innovación, give a lot of support to the researchers and always try to make them work with the users. It's something that I really love of my state. In there they have a lot of support, and they don't let the researcher alone. I'm gonna help you, not just with money, not just with that, it's with real help. You need someone expert in this area, I'm gonna put to you. For example, the first time I work with intellectual property, I have no idea, and they give all the chances to do it. And right now that we are moving, they have a program which is called De la Ciencia al Mercado, from science to market. And in this program, it's I want to take the researcher, I'm going to take him from the lab and move it to where it's needed. And that's amazing. So I think we need the three parts.
Thank you.
Thank you very much, Dr. Rita Fuentes, for this nice talk. I hope that in the future she's going to talk also about the use of nanotechnology in smart agriculture, because it is important. Yes. And you know that the Institute is leading in nanotechnology application and so on. So that is going to be very interesting.
Yes.
Thank you very much. We really
Thank you.
enjoy your talk.
Thank you, thank
your
you.
talk.
Thank you
so
so much.
let us give a recognition to you. Thank you very much.
Thank you so much.
To the general public, thank you. This is part of the seminars that we organize in this Institute of Advanced Materials for Sustainable Manufacturing, and we will see you at the end of this month in the fourth seminar. Thank you very much for all
Thank
people,
you.
all the audience. Thank you very much.
Thank you, doctor. Thank you so much.
Vamos a sacarnos una foto.
Sí.